Hi, I'm Melissa, and I think AIX is an underappreciated operating system. That might be just me. So like I said, we're from Navy Federal Credit Union. I've been with NFCU for 8 years. Prior to that, I was with Northrop Grumman on a DoD contract. And my background is AIX and a little storage, but primarily AIX. So I have a soft spot for that operating system, but that's okay. Yeah, I didn't forget you. This is Alan.
So I'm Alan. I've been with Navy Federal Credit Union for 3 years now. Before that, I was at a hospital, and so I've been working with. I started with AIX about 12 years ago when I started there, and then that's all they had was AIX. So that's what I jumped into, and I learned the hard way a lot about AIX, not as much as Melissa, but I learned about it, and then we started bringing in some Linux. So my experience was basically trying to be as lazy about administration as possible. I think that's a good way to be an administrator. So I tried to script everything I could, and so my experience from the very beginning was trying to automate as much as I could, usually using shell scripts. So that's my experience.
So a little bit about NFCU. We are the world's largest credit union. At least when we left, we were at 7 million members. Since I've been with Navy Federal, we've been growing about 500,000 members a year. So it's obviously when there's growth, that rolls downstream. More customers, more members means more applications, more servers, more storage, and so on and so forth. And not always more people to help manage that growth. They've been around for, what's that math, 84 years. So as you can imagine, as an older company, there's a lot of legacy tentacles with the applications and the infrastructure. I like to think of it like a science experiment where amoebas just kind of spawn out, and you can turn something off and you don't know what that's going to impact. It's exciting. So that's kind of what we're dealing with on our side of the house. Our team, we have 10 Unix administrators, 5 of whom have a primarily AIX background, and this not including myself. 3 have a primarily Red Hat Linux background, and we have 2 that are new to Unix in general, so they're learning both sides. The years of experience is heavily slanted on the AIX side. If we add up everybody's time in, it's 136 to 52. There's an age joke in there that we don't have to get into. We have a very tight change control process. Work is heavily measured and scheduled and planned. We have at least 2 applications where we track work. We have an HP ticketing system and an HP project management system. They don't talk to each other like they should. So your projects are planned a year in advance, and your tickets are planned 2 weeks roughly in advance. Internally, when we started the Chef project, we started asking the question, can our engineers contribute to open source, since we're benefiting from it? That's become a question that's not yet answered. That question is going to the actually the Gartner Research Board to figure out what we can do with it, and how the company as a whole wants to leverage open source in the environment now that we've brought it in. What do we do with it? And obviously, as a financial institution, we do have to meet the PCI FFIEC standards. And that in the keynote that was kind of touched on, that makes things difficult. It just does. Everyone knows that. So change control, we have at least 6 types of work requests that engineers have to handle. A potentially impactful production change we call a normal change. We have a standard change that is a non-impactful change to any environment, and that will remain standard until you do it poorly and impact production. We call a request fulfillment. We have a service desk queue where someone will go directly to service desk and that'll come down. We have change tasks where you're working on someone else's change. We have incidents that are obviously things broke. We have problem management tasks where you're working a wide scoped problem and you have a task. The fun part about that is they're all in different queues in the same ticketing system. So when you log in, you have to check at least 6 queues to see what you're going to do that day. As we discussed, production changes about 10 days in advance. We're allowed to work on production on 2 days a week, Tuesdays and Sundays. So you have to obviously compete with other groups that are trying to get that same window to take down the same systems to do other things. We average 6 moratorium days a month because we service the armed forces and their paydays are blocked out for our work because it's obviously more important that their money posts than we patch a system. And November and December are closed for changes, holidays, people aren't there. So this is how we get a request to build a server.
Yeah, so speaking of all those change requests and everything, this is, so the theme obviously is going to be Wizard of Oz, right? So this is Kansas. This is where we started off with. It's a process, right? So Melissa mentioned we have forms that people can fill out, and those requests come down to us. So in order for just a server to be born, and a lot of people give me like blank looks when I say this because for most people it's really just click a button and it's good. But for us, customer has to go in and they have to submit a form, and on that form they have to attach the project that server exists within or will be built for. And so if you don't have a project, you can't have a server. So there's a whole load of stuff that goes on even before we can get to this point where we start. And we don't do Windows, but it's the same process. So once they do submit that form, it comes to us as the admins to actually assign host names. So we have to figure out what their product is, and if they already have host names, then we have to provide something like inline. We have a very set standard on what our host names are. So we have to provide that, and we as the admins don't have any hooks into our DNS. So it goes back to InfoSec to approve the tier. So they decide whether it's non-secure, secure, PCI, DMZ, based on the form that was submitted. Once that happens, it goes to the DNS to get their DNS approval. So as far as time frame, what we're talking about here is not the seconds that most people are used to. So the customer submits the form, that takes just a little bit of time. Usually we get this request to get the host name pretty quick. So I mean, that could be within the same half a day. And then InfoSec will take 1 to 3 days to decide what tier it needs to be in. DNS cannot be provided on a moratorium day. So that could take anywhere from 1 to 3 days to get DNS in. And then we finally get to the point where we're building our servers. And that's where we actually can take over, and that's where we started with trying to make the difference in our organization to try and make things move faster. We'll show you the build process here in a second. Oh, here it is. So go ahead, back. So old build process in Kansas was somewhat automated, but mostly manual. This should look familiar to anybody who's been building AIX for a while. Satellite on the left was a little bit more automated. It was Linux. I always say Linux is easy. You can do anything in Linux. It gets hard on the right-hand side. So we use NIM to actually install the operating system. Before we do that, we have to go actually define the LPAR on the machine. So that's physical clicking in and out of forms within what we call the HMC. So that takes some time. Once we get that LPAR defined, it gives us the storage, the max that we need to get the storage assigned. So then we have to go to the storage team, get storage assigned, and then eventually it's ready to get installed. This is when we use NIM. So that process takes at least a day. Then once the OS is actually installed, which takes the few minutes that you would expect, then we had some sort of automated, but we had to kick off those automations, right? So we had scripts that were written over time. Some of them were in central locations where everybody used. Some people had their own individual scripts that they used, and so build processes at this point become very
Variable.
Very diverged. I'll say they become very diverged. And then that whole process could take us with storage and getting everything done, depending on the workload from those other, 5 ticket queues we have to work on. That could take another day or so. Once we're done with that, we have to submit tickets to backup and then to monitoring, essentially, to get that done. So the whole build process that we tell people the lead time we need.
So we advertise a 5-day waiting period, right, for your server. If it's a moratorium, that obviously can take longer because you're waiting on the network team to have the ability to do firewall rules, so you can build into that network. You're waiting for the IP assignment, and you're waiting for, before any of that, you're waiting for information security to review the form where it states what kind of data you're holding, so they can manually score it and say it's PCI, no, it's secure, no, it's this thing. And
if we go back, if there's any error at this InfoSec tiering or
any
it's tiered the wrong way for whatever reason, humans make mistakes, then we have to essentially go back to that tier, and then it gets re-tiered and we start all over. So that's the old way. That's what we were trying to improve and get across, that barrier of taking so long to deliver systems.
So this is, when we talk about growth rolling downhill, this is where we really see it. So I became team lead of the group in, I think, 2012 time. By 2013, we had 8 people on the team. We had a little over 900 systems. And 4 years later, we've pretty much doubled in size on the server count. And we've added, I would be counted as the 11th FTE, which is a misnomer. I mean, I don't have time to do that anymore. So I'm like negative help from that perspective. So 10. And it's a high ratio. It's a high ratio in a non-automated environment in particular. The closer we got to 1,000 servers, alarms started going off. We need a better way. On AIX, we were managing the whole thing with Dish, and that's great. It works. If it doesn't work, at least it doesn't work consistently on 1,000 systems, right? But to Alan's point, as we add people, to piggyback on the chef theme, you get more cooks in the kitchen, and you're bringing in senior people, and you say, this is how we do things, and maybe they do it that way by the letter, and probably they don't because they think, this has the same net effect, but it's a little different. And so we would find that in the drift, when we're patching a system and it doesn't behave 100% the way we think it should. And so we really needed a cross-platform way to make sure that we were managing all the AIX things the way they needed to be managed, and all of the Linux things the way they needed to be managed. And it was really important to me to keep both teams together, because I think everyone would rather a 10-week on-call rotation than a 5-week on-call rotation. That's kind of the threat I would always throw out there. And so this is, sorry. So we don't do WPARs. My boss is like religiously against WPARs. If he sees the YouTube.
That'll actually come up in part of what we're going to talk about, some of the technical things that we had to get over and work around.
But we are, to that point, we are about 97% virtual. So heavy on VIO, heavy on VMware. Nowadays, we have a smattering of Linux on Power as well. It's an outside conversation about that. So about 2014, we kind of narrowed down 3 things we wanted to look at. Quest was kind of the big corporate-y tool, right? It had a GUI. It was pretty. We didn't think it was a good fit for a lot of the things we were doing. It wasn't quite customizable. We looked at Puppet and we looked at Chef. One of the big factors for Chef was that stated partnership between Chef and IBM. IBM is all gung-ho on Chef, and that's 50% of the environment, so that was a kind of a win there. And with our project management cycle, we picked the product and then we got to wait a year before we could do it. So we took advantage of that time to start looking at our business processes. Like, what are we doing via script or via someone remembering to do it? And how can we put that in Chef? Since I get to play manager sometimes, what I did was, we have our annual review process, and I assigned everyone as a goal the online Ruby class. And I said, okay, we can't really work in December and January, but now this is something you can do. You can do it during business hours. I strongly recommend you do that and tell me when you've done it. And I did 40% of it myself. So that was cool. I got to play. And so once everyone kind of finished the Ruby class and we licensed the product and built all that stuff, how do we get people actually in? And what we did was we grouped everyone into pairs, and I used the word curmudgeon with affection, and kind of the understanding that people tend to think of AIX people as a little rigid in their ways. I think that's universal for Unix people, but so we had a curmudgeon and an evangelist, so someone that was a little reluctant or a little hesitant about the process in general, and someone that was really excited about it. And if those dividing lines tended to be someone on the AIX side and someone on the Linux side, then so be it. So they were paired together, and they were assigned a pretty simple cookbook. Alan would supervise those sessions. And we also had Alan kind of lead a weekly brown bag session. And here I should add that the team is remote. We have 2 permanent teleworkers. We have one in Florida. He's kind of by himself. We have 2 in one. We have 3 different buildings in Virginia where people are located. So there's not a lot of FaceTime where everyone gets together. So we had video conferences and online things once a week where Alan would pick a topic and kind of run through it about Chef. One of our teleworkers renamed the meetings the "What the hell is Alan talking about" meetings, which is true. That's very true. And so at the end of the day, what we did have going for us is everyone liked the idea of Chef. Everyone realized that we're on call for all of these systems, and the number's not getting smaller, and the eccentricities of the systems are not getting fewer. So everyone at least agreed that the end state is good. We want that. We want everything to look the same. Maybe not everyone was super excited about learning how to code a cookbook, and there was some acceptance on my part where I had to say, you know what, that's okay. You're not all going to be awesome coders. You weren't hired to be awesome coders. You were hired because you understood the OS or you understood the hypervisor, and that's your area. But at the end of the day, you do have to manage a system that's controlled by Chef, and you at least have to be able to read a cookbook and see, okay, this is what someone wrote and why it didn't do what it was supposed to do. We kind of at this point, I would call it a little bit of phase 2, where we went a little outside of core operating system management to As someone was assigned a project, or building an environment for a new application, okay, you have to take that and you have to put these requirements into a cookbook. So we're putting in MongoDB, then write a cookbook where you're building out what the MongoDB file systems are going to look like. And that's a lot of looking at another cookbook and doing a find and replace on slash whatever to slash Mongo. But it gets them in and it gets them familiar with that process.
So what we ended up with at the end of the day, and Melissa's being nice, our split is more 60-40, heavy on the AIX side. So what we ended up at the end of the day is we wanted to make sure that we had a single pane, right, of administration. And so if we were configuring, in my favorite go-to because it's easy, is NTP. So if we were configuring NTP, we wrote obviously one cookbook that's going to be applied on both AIX and Linux, and the logic in there to decide how to actually do that thing. So different service names, whatever had to be different, have to all be taken care of with inside one cookbook. Sometimes we had logic inside the default to run an AIX cookbook or to run a Linux cookbook. Sometimes they were all converged into one, depending on how difficult it was. But some quick numbers. When you're looking at like Chef Manage and you see how many resources are being managed per run, we ended up managing around 318 things on Red Hat and about 185 things on AIX. And that's not to say that we are managing Linux at a greater rate, right? We're managing our configurations 100% through Chef, just less things for some reason on the AIX side.
Because it doesn't
have a one-to-one
need
mapping.
as many things tweaked. Just saying.
Yeah, but what we ended up with the end is we had that, and we went from lab, right? So we have a very strict change control process. We went from lab, we went into production, and we only broke 4 things, and I think that was awesome, right? So we took everything that was in lab, and over a fairly short amount of time, shoved that all into production, so we were managing everything, and we changed a whole bunch of stuff. We found configuration drift in every environment on most of the servers, and we fixed all that, and you see it running through, and you realize how much was kind of going behind in the backgrounds as being wrongly configured. Not broken necessarily, but wrongly configured. And we only really broke 4 things. And that comes down to really those processes were taking advantage of bad configurations. So they were doing things that they shouldn't have been doing, SSHing as root or something like that. So those broke, and so now we have this sort of side project to get rid of those problems and bring those back into submission to Chef, right? So I think that was really good result. From that, when things started breaking, I decided to create staging environments. So in our lab, we have a staging environment, and then in production, we also have a staging environment. So we have a subset of the servers, and that makes everybody feel a lot more warm and comfortable about pushing stuff out. So there you go. Now, if you're a Chef employee, you should probably stop listening. But Test Kitchen was not a fit for us. And one of the things comes down to religiously against WPARs. I asked the question, I was told absolutely no. It also comes down to our processes and how we manage things. We don't have access to DNS. We can't just spin up ephemeral anything, much less ephemeral AIX. And again, it's easy on the Linux side because we could just run any number of things that are running through your guys' head. Why didn't you use this? But we want a single pane of administration. We don't want to have to do something differently for AIX than we have to do for Linux. So really, when it came down to it, could I have made it work? Sure. But you have to think about the level of effort that you can put in at any given time and still make decent progress. And so I banged away at it for a while, and I sort of got it working, but then I realized that to repeat this and to teach somebody else was going to take quite a lot of time. And so it was like 2:30 on a Wednesday, and I got tired of doing things the hard way, and I said, forget it, I'm going to write a simple shell script to fix this, and that's what I did. So Test Kitchen wasn't a fit, so I wrote a couple shell scripts to replace it using Chef tools, so I'll get there. Burke Chef really didn't make sense in the way we do things. Maybe it does now that I have more knowledge, but at the time it was super confusing. Again, we have a fixed dev environment, so, and this is the truth, when we have an administrator who's going to be working on Chef. They have an AIX LPAR to test on, and they have a Linux server to test on. There's not like go grab one, like they have them assigned to them because it's very steady. Now we've made some progress in time, and this will all be re-architected, but this is how from a super old system we tried to get everything working as quickly as possible. And we got it in within a few months, so it worked out pretty well. And our servers obviously have 0 internet connectivity, and if you're a member of Navy Federal, you're happy about that. So, these are the things that we had to overcome.
Okay.
Oh,
I'm
so you
trying
go
to
to the
do things.
well, you gotta do my slide.
I know. I'll get to the thing.
Wait, what'd you do? Oh, you've undone it. I had a smoke and mirrors slide. We'll show it later. All right, here, let me, if I can do this. Not my laptop. Yeah, there. But now I can't see what I'm doing. I just need to make it bigger so everybody can see it, but I can't see where I am. I'm completely lost doing this backwards.
Navigate you over, up.
I can't even see it. Let's bring it back over here. Right? We'll make it big. All right. Go back. So this is like a demo thing that obviously is not going to work at all because it's a demo thing.
There's his smoke and mirrors slide.
Yay. All right, I got it there now. So it should have gone over, but you do your laptop for us there.
Wow.
I was trying to do it cool. All right. Goodness. So, you want to hit the pause button? Okay, so basically this is hit pause.
Did it pause it?
It went away.
I hit the button I was told.
Like it went away. Okay, I'll describe it. All right, so one of the cool things about the tools that Chef provides to us is that they can be used with the way Chef intends them to be used, but they can also be used in really cool ways that maybe Chef doesn't expect that we're going to use them. And I don't know. They're all here and they can answer that afterwards. But like I said, we had these things that we had to overcome, and we can talk about why Test Kitchen wouldn't work for us, outside the room. But essentially it wouldn't. So I wrote this thing. Like I said, it was like 2:30 on a Wednesday, so I called it Test It. I thought about calling it Taste, but I couldn't type that. So essentially I'm just going through a thing here because I thought this would be a lot smoother than actually a live demo, which I was completely wrong about that. But I built in functionality to it that essentially I think in most cases will look familiar as far as Test Kitchen goes. But I wanted to combine the new tools that we had, which was GitHub and Chef, and I wanted to bring those into a development thing that people would sort of be forced to use, right? The testing methodology is you write to the cookbook, right? You make a change, you push it up to GitHub, and then you're going to run test it. It's going to go out to your configured server, which you configure in a test it configuration file within your home directory, and it will actually run based on your options. It'll run the things that you want it to run. That's not the really cool part. The really cool part is actually seeing it work. If I do that, everything will fail. Because I'm not working on my laptop here.
It's a recorded thing.
Yeah, so essentially it gives you a bunch of information about what you're trying to do. Going into a cookbook, it knows what cookbook I'm in and what branch I'm in and all that sort of cool stuff. And so it's automatically picking that up. But this is inspec running on a Linux server, right? But the really cool thing is inspec running on the AIX server. So in order to not be able to do this through Test Kitchen, I use the SSH function of inspec. So, so it runs natively via SSH, and that was very easy to do. So I was able to get that done. This is NTP because I always use NTP. I'll let this run. It may or may not be interesting to you, but I thought it was pretty interesting. So you can pass like yrun, you can do log levels if you want, you can pass in JSON. It handles, everything comes from our GitHub repositories. So what we'll see in a second is it will actually run, so that's doing yrun. But it'll actually, you can pass JSON in as like node data and it'll transfer it over and it'll run it the way you would expect it to do. So it's going to run converge. Everything's going to do as we expected because I made this video so that it would. And so yeah, it goes up and it tells you all the things that it's going to do, the servers it's connecting to and all that. And then it runs the converge, and then you see the normal output that you would normally see through like a kitchen converge, right? So all that stuff is there, and then you can run the inspect and we see that it's actually passing the thing. So I don't remember what I did there. So let's go. So idempotency, I guess that's what I was trying to show. But yeah, so essentially, I won't go through this whole thing because it's really not, I can show everybody if you really care, but the point is that in order to get around some of the things that we, sorry?
5 minutes.
Oh, 5 minutes, okay. In order to get around the things that we had problems with, we were able to just use the same, we were able to use the tools that Chef presents. So if you find yourself running into problems like that because you're working within those environments that are sort of shut off and you can't make immediate changes, or the changes you need to take effect are going to take quite a long time, you can still use the same tools, is what I was trying to get to. And you can code around those problems. So then really quickly, if we just run through these, we created also a code review process that we called CPR because we thought that was really cool. Chef peer review, right? So in order to get cookbooks through, you have to go through Chef peer review. This was also a new process. So versioning code and Chef peer review were a new process for us. And this is the important part. This is our new build process, and everything centers around Chef. So we have our code in GitHub, obviously, but everything centers around Chef. We now have something called Power VC, and then Satellite's still on the left-hand side. But we build both operating systems through the thing that builds the operating system the best, but Chef is reaching out and converging everything on the side. So we have essentially automated builds now. So we started out with this very hard process to get it done, and we ended up with an automated build. We're working backwards down that tree where the DNS and the tiering. We're working backwards there, trying to include those things. But we've gone from maybe a day to get a server built to about 10 minutes, right? As long as it takes to lay the operating system out and to actually run Chef Converge. So.
And so with both processes, the registration piece to Chef is automated as well. So it's, Power VC, I don't know if anyone in here is using Power VC, but that's actually been a huge thing on the AIX side of the house because that is like the button, and it does integrate with info blocks. So this summer we're hoping to automate that piece where, and we have permission from the network team where we can assign our own IP addresses on that side, which is like a whole square that goes away.
But we boiled it down to separate buttons for now, but really the same process for building AIX and Linux. So as easy as it is to build Linux, which is always super easy, it's just as easy to build AIX with Chef the way that we've architected it now. So.
Right, and another note on Power VC, since we do have the storage team under the same umbrella, mine, I was able to tell them, hey, we're going to do this, and give us lots of storage. So that's another square that goes away. And this is, I guess, phase 3 is what we're going to call it, where we're bringing our peer teams into Chef. So we're starting with our middleware team, which we're primarily a WebSphere shop. So Alan gets to do his whole thing again with pairing people up and doing the brown bag sessions, except now they're daily and not just weekly.
So do you know the chef recipes globally by your middleware team?
Not yet. So they're this is a new thing for them. So we're expecting in the next couple months that they'll be in that.
So they're literally practicing their cookbook skills, hopefully, as we speak.
Yes. They have homework.
I left them with the homework to do that. So yeah, I guess when it really comes down to it, you can work inside of a really closed environment that you can't change. And even with AIX, you know, the curmudgeonly operating system, Chef works perfectly. And really, I'm agnostic now because I have Chef and I don't care what things are running on it because I configure them all through the same pane. So.
Any questions?
So your change really is for the new systems, right?
No.
You have to go back and re-provision and go through the whole process for the existing environments?
Everything that was built is in Chef. So we're not building new.
Yeah, so we,
Mix of pre-chef and post-chef?
no, we don't have any of that.
When we found differences that had to be corrected, we just corrected them. I mean, we did have to skip a slide in there, but there was a period of time on the team where that process was new, and so we had to kind of restart some brown bag sessions on, okay, if you run into an issue with a cookbook deployment, the default response is not let's stop the Chef client, it's let's figure this out and put it where it needs to be and keep it in Chef.
Good question.
I saw you use satellite. How did you decide what goes into a chef book and what goes into satellite?
So,
Systems?
yeah, so the question was, we use satellite, so how do we decide what satellite configures and what cookbooks configure? The easy question is cookbooks configure everything.
Yeah, so satellite and now Power VC or NIM, whatever, I mean, their sole responsibility is put the OS on the box.
So how do you react to some updates that you must make for addressing a security issue? Do you make a change in the cookbook and then wait for the convertible to go through?
So if you're asking about how do we respond to changes that we have to make for our security standards, if you're talking about packages, right, updates to the operating system, that's definitely handled by satellite. It's managing the operating system packages as far as that goes, the versions of the packages and actually patching them, but it's not managing the configuration of those things. So if it's a configuration change that has to be made for security standards, then we go back to the cookbook, we make that, and we push it out at whatever speed is necessary for the threat, and it goes through, and within 40 minutes our entire fleet is patched.
So are there any special requirements for running Chef on AIX? Did you have to prep any special images? You mentioned LPAR versus UPAR.
So we didn't have to do anything. I mean, they have a package. We installed the package and ran Chef.
So there's a client for AIX.
Really easy.
There's a client for Linux on P, and that was it. I mean, the team has some religious arguments about Bash on AIX. That's about that. That's about it.
What version of AIX do you run?
So we have secrets. So we the supported versions that we run. So we have 7.1, 7.2. We have some 6.1 that is supposed to go away by the end of the year. Those are the levels that Chef clients are on. We do have some 5.3 as well, extended support agreements. 5.3, we pretend that doesn't exist. We don't have a Chef client on those.
Did you find the environment cookbook pattern useful, or did you come up with your own?
So the pattern we use as far as like registering the servers and how we do those, we do it what is probably considered the old way. We have environments that are essentially the environment and the location. So we have a Vienna data center, so it would be VDC Lab, VDC Prod. That's the main environment breakdown that we have. And then we actually have roles, which I know is not necessarily everybody likes roles, but we have roles, and so we put every server goes into our server role, and that's how we actually send out our configurations, and then they also have their app roles that we put them in. So it's environment, role, and cookbooks are all applied to roles, and we don't put anything on node data that is responsible for configuration of the server. Okay.
Okay.
Yep.
Thank you.
Thank you.
Thank you.